Up next, the future of AI panel discussion and Q&A.
Good morning and good afternoon, everyone, and possibly even good evening, depending where you are in the world. So I'm Dr. Jeff Hudak. I'm from the Air Force Research Laboratory, and I'm going to be leading this really great panel discussion on the future of artificial intelligence. And so I think we had some really great keynotes from Dr. Jode and Dr. Pekarsky. And what I really loved about those talks was that they spoke to the diversity of technical challenges. Actually, not even just technical challenges, the diversity of challenges that are involved when we think about collaborative autonomous systems. And also the complex interactions. You can't solve any of these problems in isolation. They have to be considered together, and inevitably it makes for, from my perspective, a rich and amazing research area that none of us are going to be able to solve on our own. And so I think Dr. Jode had asked if folks from New York are representative of all the United States. And I can say confidently, yes. As someone from New York, New Yorkers are the best representation of what the US has to offer. But seriously, one of the things that makes the US and frankly this world as strong as we are is that diversity. And we all have diverse perspectives and backgrounds, and frankly, local cultural influences that give us that unique perspective and allow us to come together to solve problems. And so that's, for me, what makes this US-UK event so amazing, is that we get to come together and then reach out to the larger world to help us solve those problems. And so, so today, my panel with me today is, first we have Mr. Fraser Baker. He is a research scientist at the Advanced Concepts Laboratory at the Georgia Tech Research Institute. And his research includes neural networks, modeling and simulation, reinforcement learning, machine learning education, and also bioinformatics and data visualization. So he has a master's degree in computer science, and his focus has been on data mining, visualization, and machine learning. Next, we have Dr. Eugene Shepherd. He is a researcher on autonomous systems, sensors, and navigation with over 10 years of experience with the Navy. And he's also an adjunct professor at the University of Rhode Island, where he teaches biomedical, electrical, and computer engineering. Also with us today, Professor Mears. He is a fellow at the UK's Defence Science and Technology Laboratory. And he specializes in the application of artificial intelligence and machine learning to defense and security challenges. And so he's the head of DSTL's AI lab and provides advice on the responsible and safe adoption of AI at the highest levels within the Ministry of Defense at the UK. He is also a visiting professor at the University of Southampton, working with the Center for Machine Intelligence. Also, Dr. Corey Schumacher, he's a program manager and research engineer for the Air Force Research Laboratory, with interests in flight control, nonlinear and adaptive control, cooperative control, optimization, AI, and autonomous systems. Dr. Schumacher has a doctorate in aerospace engineering from the University of Michigan, a master's in business administration, and is also a graduate of the Air War College. And finally, Jason Blackford, also from the Georgia Tech Research Institute, is a software engineer who's done game development and AI research. He has a master's degree in computer engineering from the U.S. Air Force Institute of Technology, and served 7 years in the U.S. Air Force. And so before joining GTRI, he led a number of projects for mobile gaming, PC gaming, and serious games, with over 8 years of experience working with Unity 3D. And so we really have a fantastic panel here today. And so I'm really excited on the discussion we can have on some really emerging topics and what the future of AI is. And so to get us started, this is the future of AI discussion. So let's start thinking about the future. So the last Swarm and Search AI challenge we did in 2019 was a firefighting scenario. It focused on a single team and how they can coordinate and deal with uncertainty. This year, we decided let's try something adversarial, and I think we've heard all sorts of really cool discussion about what makes adversarial challenging, both from our keynotes and the interviews with the teams. But what's interesting is it adds this sort of opposing force working against you as you're trying to achieve your objectives. So I'm going to go around the panel, and really the question here is, what do you see the critical AI challenges that can drive research? And really, what could we maybe focus on in the next challenge so teams can start thinking about this and already start hatching their strategies for the next competition? So why don't we start with Fraser? That'd be great to get your thoughts.
Yeah, thanks, Jeff. So in this challenge, of course, the adversarial component, the sort of offensive strategy that you could employ was the jamming of communication. So you had a jammer that could sort of, or not communications, rather, of sensing, that could reduce the sensing radius. And I think that was a good start. But something that I've been thinking about as I've been watching this is, what if you had something that could sort of make an agent stop or pause, something that was a little bit more disruptive, because we saw that some people use the jammer just as another searcher, right? So maybe there needs to actually be more adversarial techniques available. And I think you could also just add multiple different types of offensive strategies, have different types of agents in the scenario for people to play with.
Great, thank you. Dr. Shepherd, your thoughts?
Yeah, great. Yeah, I think one of the things that from the last competition that was really interesting was the environment was also an adversary. And so that part I think we commonly overlook is really hard to understand the environment. And that really could play a role in the next event is, how could I develop a model of an environment which I don't know how it's going to evolve over time? And so that from a research perspective is really deep, but also from just application, as we want to bring technologies to the DoD or other sectors, is how do we deal with this complex, uncertain environment?
Yeah, certainly. Professor Mears, your thoughts on the next challenge and what the AI challenges we could face?
Yeah, thanks, Jeff. So I'd agree with what Fraser and Eugene have both said about kind of denied and degraded environments and how the swarm can adapt when your environment is operating against you, but also the kind of adaptation in the sensory environment. So the kind of the degree to which what you're trying to sense isn't stationary, which things are changing. On top of that, one thing I would add to that is the kind of challenge of robustness. So, as your system encounters those kinds of adversarial, whether it's from an opponent or whether it's from the environment, how your system recovers from failure, how it degrades gracefully. So, as well as those two challenges, I would add the challenge of robustness and recovery from failure.
Excellent. Yeah, no, that's an excellent point. And also, I think robustness is, in a sense, how you plan ahead of time. There's reaction, but then there's that preparation. Excellent.
Yes.
Dr. Schumacher.
Well, as a controls engineer, my top of the item list was robustness, which has just been stolen. So let me kind of expand on that for a minute in the sense that we typically have a challenge like this, we'll train in a simulation environment. And then the test environment is generally very similar to the training environment. I'm not sure exactly what was done in this case, if there were some variations added, but I think in the future, for another challenge, it'd be great to see a test environment that is a little bit different from the training environment. So there's some surprises in it. And that way we can see whether these algorithms are highly brittle or if they've got some of that flexibility and robustness to do something a little different. For military systems, there's always differences between the sim and the real world. And so trying to simulate some of those differences in the tests would be a good thing for a challenge.
Excellent. Thank you. Yeah, with this many panelists, overlap is almost inevitable. So great, thanks for it. And then finally, Jason Blackford, your thoughts.
Yes, so doing a lot of game development, first-person shooters and whatnot, you get tired of having to rewrite your AI, different behavior trees, different hierarchical task networks, all the scripting you have to do. And boy, wouldn't it be nice to have generalized AI where you can train a couple of agents and then they're able to play different games and interact with the player in different environments and have that knowledge transfer. And so I think from a warfighter side, I enjoy personally the model simulation side, mission planning, training simulators. You could have that type of capability where you can change the area of regard, drop your AI units in, and they're able to adapt to that new environment and engage the same way they would in, maybe a desert, or now you're over in a forest or urban environment. I think that would be something to take a look at. I also think, again, hitting on being able to reason about the goals and motivations of other agents or your human opponent in real time is critical, especially for mission planning applications where you're developing courses of action over the duration as it plays out. So having that adaptability is needed. And then, of course, the big question for a lot of us is always the data question. I think having a better way to generate data, synthetic data, and seeing, okay, what does synthetic data bring to the table, given some of these state-of-the-art game engines like the Unreal 3D engine or Unity, how can we leverage some of these for some of our sensor training, whether it's ATR or, automatic target recognition, things of that nature. So I think there's a lot there. Again, I would probably go back to generalized AI, that knowledge transfer, and then reasoning about your opponents, like we're doing a little bit here in this adversarial competition. But that generalization is so important. And so how do we generalize?
Yeah, excellent. No, thank you. I think certainly a common theme for all of the responses is adaptability. And honestly, that is that has long been a challenge for machine learning and AI in the research community, and continues to be a challenge. And I think what's interesting about it is that it's not just adaptability, in this case, to an adversary, but like it's been said, the environment. In some cases, it could be how do you adapt to the bias of the data that you've collected? As humans, we're collecting data for a purpose, and often that data is used to train a model that is used to do something that maybe was not intended. And so, yeah, I think it certainly hits on a very larger theme of the challenges of AI in general, and how we can build systems that frankly can operate in the real world. Because even this competition, while challenging, is still a far cry from the things we're going to have to deal with in the real world. So excellent. It's good. It's good we all have strong agreement on this question. So the next question is, I think, really driven by some of the challenges that Dr. Job mentioned in his brief, which was really how do we understand and have a system explain what it's doing. This is key for helping the system get better. It's key for interacting with the system as a human. And it's really I believe, the underlying foundation for trust and ethical application of autonomous systems. And so I know that from my perspective, from the Air Force, one of the recurring challenges that we have is questions about how we can effectively command and control a single or a collection of autonomous systems to ensure that they're actually executing the intent of the human. And so are you as a team seeing any trends or critical barriers to ensure that the systems are doing what we expect, and how we can really, frankly, control them and make sure that we understand them? So I'm going to go in reverse order this time, and we'll start with Jason for the first response.
Yeah, it's a hard problem. I know there's a lot of research focused on trying to understand what an agent is doing, because let's face it, a warfighter wants to be able to trust that agent is giving them a reasonable answer. And that is some research we have here. Part of what we've tried to do, especially in the deep RL side, is to expose that state representation and say, okay, warfighter, this is the state representation, how the AI sees the world. And then this is what it's trying to do, its actions that it can take within this world. But then also, how do you take a mathematical representation that's described and hidden inside these layers of networks and show a decision surface that is human, that's intelligible to human being? And that's something we're still trying to, we have a project where we're trying to bring that out a little bit. We have some nice charts and show decision surfaces. But again, trying to make that something that an operator is going to be able to look at and say, oh, yeah, I trust you, is a hard question. I know some of our sponsors, a big thing is human machine teaming. So, the focus there is being able to allow the operator to have trust in the agent. And at the end of the day, it's still very much an open question, and we're experimenting with different ideas, and we'll see what happens.
Yeah, and I can't help but think of sort of this ongoing running joke from the video game community of NPC helpers, non-player characters that are AIs that are supposed to be your teammate. And historically, they are very good at getting in your way or not keeping up or running too far ahead, and you have no insight into what they're actually doing. So I think it's certainly something that many folks from different communities can understand. Even my little robot vacuum, I'm sometimes wondering, what in the heck? Why are you stuck under the chair again? What is wrong with you? So great, thanks, Jason. Dr. Schumacher.
All right, so I think we've got two parts to an answer, and one of them is the question of being trustworthy. The system, the first step in getting the humans to trust it is having it actually be reliable and effective at the tasks you're asking it to do. And I've seen cases where people are studying trust on a system that doesn't really work and it doesn't do what you want. So how are you going to get the person to trust it is the wrong question, because they shouldn't trust the thing at the stage it's at. The other part of the question, as it was sent to us, that's really hard, is it's talking about understanding the intent of the human and how is it doing. So it's pretty easy to make it, no, not easy, but it's much more doable to make it reliable and effective at a well-defined task. But intent is often extremely difficult to determine in a more complex mission environment, because a person who is told by their commander what to do doesn't necessarily understand the commander's intent perfectly. And they're drawing on their training and experience and sense of morality and a long history of operating with these people to try to understand what the intent is. The autonomous system doesn't have most of that background. And so as we try, it kind of touches on one of the previous answers of getting more generalized artificial intelligence. If we wanted to parse the intent of the humans in some meaningful way, they have to get a whole lot smarter in general and be able to understand whatever understand means in this context, more complex concepts.
Excellent, thanks. Yeah, I have some interesting thoughts on C2, but I want to make sure we give everyone a chance to answer first. Professor Mears, I'd love to get your perspective.
Yeah, of course. So I've got 2 points I want to make. The first, I think Jason kind of touched on it, but too often I think we consider this as the human kind of interacting with the system. I think we need to recognise that the human is part of the system, and that we need to engineer. Jason used the phrase human machine teams, which I think is absolutely right. And in some of our experiences in the UK, some of the failures and the accidents that have happened have occurred not because of a failure within the autonomous agent itself, but to do with a failure that happens across the human-machine interface. So an example of that was one of the crashes we had of one of our watchkeeper systems, which is one of our surveillance autonomous vehicles, where the state representation in the drone was very different to the understanding that the human operator had. He decided to override the behaviour of the system, and that was what led to the accident. So I think for me an important point is that we engineer them as human-machine teams. The second point I want to make is that as a kind of an overall trend, I think we're seeing a degree of kind of over-optimism and overconfidence about the resilience and robustness of these systems. Industry providers are incentivized to bring products to market quickly, which is great. And we need to encourage that, because that's how we learn and experiment and adapt. But I think we do need a lot more maturity of understanding of the failure modes of the vulnerabilities. A kind of a concept that we're beginning to explore within the UK is that of an AI vulnerability investigation. So for many years we've done cyber vulnerability investigations, where we use red teams and a variety of different approaches to assess the vulnerability of our networks to cyber attack. For me, I think exactly the same rigor and kind of culture needs to go into how we understand vulnerabilities in autonomous systems as well.
Yeah, I think a great point about the human machine are really as a team and those interfaces. I think the 737 Max scandal that happened it turned out just ended up being a combination of the interface to the system and how the system itself worked and the training of the pilots and how to use that system and the fail-safe methods. So I think that and challenges we're seeing with autonomous driving vehicles and people deciding to sleep when they're not supposed to be sleeping are just great real-world examples of problems that we have to address and really think through if we're going to apply autonomous systems. Excellent. Thank you. Dr. Shepherd, your thoughts?
Yeah, I think to follow on some of the earlier comments, I think as you want to work with these tools, right? We're treating them autonomous systems as tools, and the AI is a tool. As animals, we've learned to embody these tools so we can figure out how our actions will translate into an effect with those tools. It gets challenging when we talk about these AI in a defense context. There's a lot of strategy guys that really talk about how it's unique for the Navy. Like one example being, if there's a blizzard, we might just say no one can drive on the roads. But for the military, we have to be able to operate in these extreme conditions. And so how do we embody and translate into these machines that are foreign to us? They're not humanoid robots, and especially the long duration missions. That is really, I think, the challenge is how do we translate through the embodiment of these platforms? There's not a lot of feedback with these systems, especially for the Navy perspective. When we hit launch, if it's an undersea platform, communications are pretty poor. So that embodiment and communication is low, so trust is a challenge. The other thing that I think often gets overlooked is we say human intent, but for us is really conveying what the constraints or assumptions are and how do we map that? Because if it's a human and we embody, like I talk to my child and say, hey, can you go do this task? Given these a human, we might understand what assumptions and constraints he might apply to the problem, but we don't know how to map that to these other platforms yet and communicate it. So again, I want to leave time for other people, but those, I think, the embodiment and how we map constraints and assumptions, I think, are a really big challenge.
Yeah, and I think there's the converse problem as well. It's how do we impose our knowledge on the system, but also I think there's often challenges with the users assuming that the system is smarter than it really is. Oh, it's a autonomous AI. Wow, it must know what's going on better than I do. And that's rarely the case. And certainly as I interact with my toddler, I realize, wow, this is pretty much what AI is. It's a toddler that will follow orders as I give them, but with very little understanding of the larger context. And so I think that's certainly a key challenge as we talk about how to integrate technology into human processes. And so finally, we'll go to Fraser Baker.
Yeah, so Jeff, kind of following on some of the things you've said and everybody else has said throughout, I think there's a general misunderstanding of what the current state of machine learning and AI can do, right? How much it really understands, as you were saying, about the context and what's really going on under the hood. If I say AI, you're going to think that this is some, super smart computer that knows how to think even better than a human. And generally the gold standard, if you can get human level performance out of something, that's fantastic. And in the majority of cases, you don't get there. So I think that, maybe in the future, someday we will have that. But in the nearer term, helping to train people, to educate them that, what we have today is not general intelligence, is more specific intelligence. It's trained for, a certain set of environments, a certain set of inputs. And if you take something that it wasn't trained on, it's not going to understand how to generalize in most cases very well. Obviously, you want to get there, and that's a big problem. But I think for the tools that we have today, that's an important thing to explain in terms of improving trust. In terms of improving the ability to command and control these systems, I think a lot of that comes down to knowledge representation and that in the representation of the intent. I know other people have touched on this, but it's hard enough for a human oftentimes to understand what the commander actually intended. So being able to represent that in a more concrete way without requiring the people who are making these commands to learn some sort of code, there needs to be some middle ground in the near term, right? There needs to be something that it's not somebody writing, if we wanted to hard code the autonomies, then why are we making them? Then how are they really autonomous? But some sort of instruction set that can be given that's maybe at a higher level. It's a really challenging problem, right? Because at the same time, then once you have given the command, if you want to continue to control, you also need to understand what's going on inside the AI. And a lot of times that's so densely numerical. There are so many numbers, weights and biases that are getting multiplied and added that for a human, that's really not how we operate, and it's really hard to understand. So being able to represent that decision surface, going back all the way to what Jason was saying, in a way that is comprehensible is, I think, another big challenge. I don't know if I gave you a lot of answers, but a lot of challenges and questions, and I think that's kind of where we are.
Yeah. So no, thank you. I think along those lines, we have a question that I think is very relevant to your last comment, which is, and I have to agree. Sometimes it's easier to talk about the problems than it is the solutions. But one of the questions from the audience is, what is being done to teach humans how to use AI for decision making? Are there any experts working to solve this problem? So I can give you a brief thought from, I know that the LeMay Center for Air Force or Military Doctrine has been thinking through this. It's the art of war versus the science of war, and human command and control and intent. Commander's intent, a magical term we like to use, is very much an art form, and it's an exercise in trust and vulnerability, really, to your subordinates, to grant them the authority to take action on your behalf, which, when you think about granting a robotic system authority to act on your behalf, sounds much scarier when you put it in that form. And so they're really working to tease out what is the line between that art and the science of war. The science of war is where the machines can actually do pretty well, the optimization and thinking through the well-defined problems. So rather than go through everybody, as I think we're getting close to end on time, just maybe raise hands if you have additional thoughts you'd like to offer, and I will call you out individually. Hey, Jason.
Yes, it was actually a Wall Street Journal article yesterday on AI. The media covers it quite a bit. And Elon Musk came out and said, yeah, we're just not there yet. So you look back a couple of years ago, he was towing the line for AI, saying it's amazing, it's going to be the next big thing. And I think industry partners in the industry and general commercial sector being honest and open about, yeah, there's limitations, is an important part. Again, totally agree. We want to keep industry moving in that direction because they've given us a ton of excellent tools. Look at what Google's provided, Tesla's provided, just OpenAI, tons of great tools out there for us to leverage in the research community.
Great. Dr. Shepherd?
I was going to mention, talking with other people in the military, they were saying for autonomy and AI, it's a little bit easier than some of the commercial sector from the perspective of intent, because we've had a lot of years where we train people on how do you convey commands, right? And so it's just how do we work from that more abstract level that you might convey intent down into actual action and constraints. And so from the higher level, I think we've got part of that communication chain sort of articulated, but now how do we do that translation and mapping? We're really still struggling with that. And that's why we're glad there's a huge commercial sector with interest in AI, right? Because we're amplifying the innovation.
So. All right, Fraser.
I'll make it quick, but I think that there's a large group of people studying human-computer interaction that are looking at this right now. I know of some people down on campus that are looking at this. And I think there's also a lot of development of user interfaces to sort of help demystify what goes on in these more complicated neural network models and things. I myself have worked on that a little bit. I have some projects that I've done just to try and integrate domain expert knowledge with neural nets, and that's a really interesting piece. How do you educate? How do you integrate with people who are not experts in machine learning?
Great, thank you. So, yeah, we've reached the end of our time. Thank you to this amazing panel. Really, these are. I think we could probably do a whole day event where we just sit and talk about these questions, because there's a lot to unpack here. So, for others who had questions that you were afraid to ask or you'd love to get answered, we encourage you reach out to us via the speakers button. I believe that's on the Socio platform. You can find our contact information, and yeah, these events are all about how we can effectively reach out to the larger community. So we're always glad to have these conversations, and we really appreciate everyone's interest in the event and in this panel. So I think with that, once again, thank you everybody, and I hope everyone has a wonderful rest of the event.
Thank you.
Thank you, Jeff.
Thank you.